All right, welcome back. So we've got an example on how to make a 5-number summary and how to use those values to construct a box plot. And there's a little bit of work, and that's okay. I promise it's not too bad, because I'll show you what I think is an easy sort of process and an easy sort of order to things. Okay, so here's the example, and I made this up too. In this class, most of the time we'll be working with real data. This is not the case. So, to continue the trend of horrible events happening in 2020, Nickelback has come out with a new album, and then some people reviewed it and they calculated their scores, and it's now our job to make a box plot and a 5-number summary to summarize those scores, so we don't have to actually read all of the values in there and get some meaning out of it. We can just look at a picture and get, I think, a better idea of what's going on. So the first thing we want to do is make that 5-number summary, because within that are the components that make up a box plot. Okay, so let's get started. What I think is the best order to do things. So this is Carsons method. Is first thing we want to do is find the median, and then after that we just want to find Q1, that 25th percentile, and Q2. Doesn't matter the order, you can do it either way. That's the second step. I think that's the best place to start. And then the third place to start is determine our outliers. Okay, and then the last thing to do is the min and the max, and then we'll put the true min and max in there too. Okay, and then after that we'll draw the box plot. All right, here we go. So I've got it here. I got a new page set up just so I can kind of show you what's going on, and I think the best way to do this. So same data, right? It's ordered. That's the first thing you want to do, is make sure that everything is ordered. And if it's not, then you should put it in order. All right. So the first thing we want to do is find that median. Okay. So it's not too difficult. Recall that all we really need to do is just whittle away from the beginning and the end, one at a time, until we get a middle value, or two values that we just take the mean of. Okay, so start here, and then we'll go here. Okay, and then we're whittling our way down. Okay, and now we're left with these two values. Well, what we want to do is, since there's two values, we need to add them up and then divide them by how many there are, right? Just taking a mean, which in this case, and it's sort of a spoiler alert, it's just going to be 3, right? And I can show you the math. So 3 plus 3, 6, and then divide that by 2. 6 divided by 2 is 3. Okay, so if you get the same, two values in the middle, then the mean, the median is just those two values. So in this case, it's 3. All right, so the median is 3. Easy enough. So we got that. All right, we're making headway. All right, so the next thing that we want to do, and I'll erase these X's here, is that our median point is right here, right? It's in the middle, right? Because we got down to these two values, and we had to take the middle point in between those two, right? Okay, so that's our middle point. So everything below this represents 50% of the data, and everything above this represents the other 50%, the other half, right? And we can double check to where we see that this is 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. And then, easy as that, right? Easy as that. Okay, so let's find Q1. So that 25th percentile, well, this makes up 50%, and this other half makes up 50%. So ideally, if we were to divide this into 2, that gets us 25% and another 25%. So all we need to do is just find the median point the median point of this half of the data now. All right, so we can go 1, whittle away, and there we go. That's our 25th percentile mark. Okay, so we just come down here and record that. And let me use a different color so we're not losing track. So that median was 3. Q1 is 2. And we just do the same process for Q3. Whittle away, and then booyah, we get number 5 here. We get number 5. Okay, so that's the first 2 steps. We found our median, right? The process is the same for Q1 and Q3. We're just kind of working with a different, like a little bit of a subset of our data. So I'll erase all this just to clean it up. And then now what we need to do is we need to find our outliers, okay? So we can go back to that formula page to figure out the process, to figure out the formula for finding an outlier. But I can just show you right here too. All right, so for outliers, instead of going through and just looking at it and say, okay, maybe this one, whatever, what we're going to do is we're just going to create sort of like a cutoff point for outliers that are really small and outliers that are really large, okay? And if any of these values fall beyond that cutoff point, it's considered an outlier, all right? So what does that equation look like? Well, let's start off with small outliers. All right, small outliers. And what we want to do is we just want to say, okay, anything that goes beyond that sort of that made up minimum is just going to be any value beyond this. All right, and that's the formula for figuring out which values fall below, or which values are considered small outliers. All right, so this fancy thing here, this IQR, we can rewrite that, I think. It's a little bit easier to understand just as Q1 minus 1.5, and that 1.5 is totally made up, very arbitrary. That's just the number that we use, right? There's some math theory behind that we're not going to worry about ever, ever. So that's fine. It's always 1.5. It's never anything else. And then instead of putting IQR, let's actually write out what it stands for. It's Q3 minus Q1. All right. We already have those values. We have everything here that we need. Okay. So for small outliers, it's going to be 2. I'll use the different colors too. It's going to be 2 minus 1.5. Okay. And then Q3, which is 5, minus Q1, which is 2. All right. So then we'll come down here. We'll work this out. So 2 minus, I'm going to show you every step too, just so we don't lose anything. Oh, I hate this. So inconsistent. There we go. Okay, so that's 3, right? And then I'll get out my trusty dusty calculator. All right, so I've got 2 minus 1.5 times 3 is 4.5. And already we can see that we're going to get some negative value, right? So 2 minus 4.5 is negative 2.5. Negative 2.5. Okay, so that's impossible in our data set, right? So any value that falls below negative 2.5 is considered an outlier. Well, we don't have that. We don't have that here. We only have our smallest value is 0. All right. So it's the same process. It's the same process for the large outliers. Same process, just a slightly different equation. Slightly different. Okay, and what that looks like is Q3 plus 1.5 times the inner quartile range. All right, so we'll rewrite that out as Q3 plus 1.5, and then Q3 minus Q1. All right. Okay, and then what that looks like is 5 plus 1.5, and then 5 minus 2, again, same stuff, same values, right? So then that leads us to 5 plus 1.5 times 3, right? Same deal, where then this is 5 plus 4.5, which equals 9.5. Okay, so any value that falls above 9.5 is considered an outlier, okay? So do we have anything that does fall above 9.5? Well, yes, we do. 10 falls above 9.5. And we don't, okay, also, we do not ever round with this criteria. Never, ever. So we see here that 10 is considered an outlier. And then also, let's say that we also had a score of 9.5. That would be considered an outlier as well. Okay, but for right now, we have only one outlier. So let's record that. And that outlier is 10. All right, cool. And then recall that when we're doing our minimum and our maximum, we're looking for the minimum and maximum excluding outliers, okay? So our minimum value just so happens to be 0, right? Just so happens to be 0. That's the smallest value because we also found that there were no outliers below, right? We found that any value that fell below 2.5, negative 2.5, is considered an outlier. Well, we don't have that. So our minimum value is 0. Okay? And then our maximum value, excluding the outliers. So we found that 10 was an outlier, so we ignore that, and we go with the next biggest number, which is 8. Okay? So we'll write that down, and look at that. We've got everything we need now. That's our 5-number summary, 1, 2, 3, 4, 5. And then we've got everything we need to make our box plot. All right, so let's do it. So I will draw a quick straight line, like so. Look at that, almost straight. Okay, and then let's see. We can just draw it from, as far as tick marks go, we can go from 0 to 10. So 2, 4, 6, 2, 4, 6, 8, and 10. The scale doesn't really matter. I know it's off just a little bit. Okay, so that's good. So let's start with our median. That's the easiest, I think. So the median is just a line, right? And our median here is 3. Okay, so we'll draw one line there. All right, that's our median. If we were to trace this down, there'd be a 3 right there, right? Okay, so that's all fine. That's all good. And then let's just do the Q1 and Q3. So Q1 is 2. Come down here, draw another line. And then our Q3 was 5, right? So that's right about here. And then all we need to do is connect them up. And that's our box. That's our box part of the box and whiskers, or of the box plot. And then what we want to do next is our minimum and maximum, right? Excluding those outliers. All right. So our minimum, good Lord, sorry if you just had like an aneurysm or something. Our minimum is 0. And then our maximum, excluding outliers, right, is 8. Right there. And all we want to do is just connect with a straight line, and that's it. And then the last thing we have is an outlier. And let me do this too. Outliers. And this is just some value, right? In this case, 10 was an outlier, right? So we'll just put a dot there. And that's that. That's how you do a box and whisker plot by hand. Not too bad. There's just a lot of steps involved. So review the steps. Try it out yourself if you haven't already. And compare what you got with what I got. And hopefully they're right around the same thing. Now, another thing to note. Box plots are very much different in histograms in many ways. One, because a box plot looks way different, but also it's not subjective at all. In that you can't really do anything, you can't really manipulate anything here to make it look different. There are set rules with box plots, whereas in histograms we were able to kind of change the bin size to maybe look slightly different. But otherwise, box plots, there are a set rule, and my box plot will always look the same as your box plot. Histograms are sort of a different story. Okay, so maybe I want to see what the mean is too. Let's just do that real quick, and we'll denote that with an asterisk. Okay, and we'll just put that down here. Okay, so all I need to do to find the mean score in this case, is just add up all of these numbers and then divide it by how many there are. Okay, so let's see. Let's put the mean. Let's put the mean down here. Okay, not always required. I'll ask you to do it. These values, the median, quartile 1, quartile 3, the minimum, the maximum, those are the 5-number summary. Okay, the mean and the outliers, I'll ask you to additionally include those. So the mean, let's do this. 0 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 5 plus 8 plus 10. Okay, let me get out my calculator real quick to do this. Plus 2 plus 2 is 4, plus 6 plus 9. Just sort of doing this by... Okay, so the sum here is 38. And then we'll divide this by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Divide that by 10. That is 3.8. So the mean score is 3.8. All right, so the mean, will just come down here and write that as 3.8. That's fine. That's cool. So we see that the mean and the median are pretty close, but it's just a little different, off by about 1 score unit. Okay, and recall that when we are trying to denote the mean on this figure, we'll use an asterisk. Okay, we'll use an asterisk. So 3.8. Let's forget about rounding. Let's just try to kind of guesstimate where that would be, which would be right about here. All right, and then that, folks, is a box plot. Look at that. A lot of steps, right? But tells you quite a bit of information. So I will stop the video here. Go ahead and try it out yourself if you haven't already. You can even, try something different. Try putting in a new value up here to see how the figure changes, or leave out a value and see how that changes. And let me know. All right. So I will see you here in just a little bit.